Hi folks, we're going to take a look at question 8E from page 126. So here they're asking us for the parametric equation of a plane that contains these 3 points. So let's recall that for the equation of a plane, what we need is we need a point on the plane, and we need 2 vectors that are going to act as basis vectors, which we call our direction vectors. Okay, so here we have 3 points, so you can use any one of these 3. And what we need to do is create 2 direction vectors. And here that's pretty easily done, because if you take this 1 point and then you use the other 2 points to create these 2 vectors that will be on the plane, so as long as they're not parallel to each other, we can use these as our direction vectors. Okay, so I'll call this A, B, C. Okay, so what I'll use here is I'll use the vector AB. Okay, and this we'll call our first direction vector. So here our vector AB would be -3 minus 2, so -5, 1 minus 6, -5, and -4 plus 5 would be equal to 1. Okay, and then our second direction vector, which I'll call B, I'll use AC. Okay, so here our vector will be 6 minus 2 is 4, -2 minus 6 is -8, and then 2 minus -5, so 2 plus 5 is equal to 7. Okay, and once we have our 2 direction vectors, we can now just write the equation of the line. Okay, so in fact I'll write it in both vector and parametric form. So if it was in vector form, we take one of our points. So let's say here I take 2, 6, -5, and I add s times my first vector, so s being one of my parameters, so -5, -5, 1, plus a second parameter, which I'll call t, times 4, -8, 7. Okay, and then if we write it in parametric form, we're just separating out the individual components when I add all 3 vectors here. So here I've got 2 minus 5s plus 4t, y is equal to 6 minus 5s minus 8t, and then z is equal to -5 plus s plus 7t. Okay, now this is a little different from the Cartesian equation, where regardless of what you use as a normal vector as a point, you should always come out to the same answer. Here we have a sort of a similar problem as we had with the vector equation of a line, is depending on what point you choose as your given point on the line and how you create your direction vectors, your answer could look very different from the one in the book, or from someone else who's doing the exact same problem. So you might want to think about how would you show that 2 vectors are in fact the same vector. Okay, it's a little more work involved than what we had to do with lines. Okay, but for now, that is it.